High above our heads, in the vast reaches of space, lies a fiery, dynamic force, the Sun. It is the heart of our solar system, a burning ball of energy that sustains life on Earth. But this life-giving star is far from static. The Sun is in constant flux, with its surface roiling in magnetic storms and bursts of energy that can shape not just the space around it, but our entire planet. One of the most fascinating features of the Sun's ever-changing surface is the presence of sunspots, dark, cooler regions caused by powerful magnetic fields. These seemingly minor blemishes are more than just surface features. They are an indicator of the Sun's inner workings, a signal of the magnetic storms that stir beneath the surface, and a reminder that the Sun is not a calm, predictable ball of fire, but a dynamic, unpredictable force. Sunspots are part of an intricate cosmic rhythm that plays out in an 11-year cycle. Each cycle is a dance of energy, rising and falling in intensity, shaping the Sun's magnetic field and influencing the entire solar system. Over time, scientists have studied these cycles, and they've uncovered patterns, understanding that they do not simply affect the Sun, but everything in its reach. From Earth's climate to the operation of satellites, the effects of the sunspot cycle reach far beyond the Sun's glowing surface. To understand the significance of sunspot cycles, we first need to grasp what sunspots themselves are. At their core, sunspots are cooler regions on the Sun's surface, but the reasons for their formation are deeply tied to the Sun's magnetic behavior. The Sun is a massive ball of superheated gas, where temperatures can reach millions of degrees. But beneath this blazing heat, the Sun's magnetic fields twist and tangle like the strings of a cosmic rubber band. As the Sun's magnetic field becomes increasingly tangled, it generates powerful magnetic forces that push through the Sun's surface, creating sunspots. These spots are cooler because the magnetic fields inhibit the normal convection currents that carry heat from the Sun's interior to its surface. However, despite being cooler than the surrounding areas, sunspots still burn at temperatures of over 3,000 degrees Celsius, hotter than anything we experience here on Earth. Sunspots are more than just stationary marks on the Sun's surface. They are often the birthplace of solar flares and coronal mass ejections, violent explosions of solar energy that can reach across the solar system. These bursts of energy send shock waves through space, releasing vast amounts of radiation and charged particles. While the Sun's flares are fascinating to observe, they also have the potential to disrupt the space environment around Earth, affecting everything from communications to power grids. Now, imagine the Sun's activity is not a random burst of energy, but a rhythmic cycle, a regular ebb and flow of solar activity. This pattern is what scientists call the solar cycle. This cycle, which lasts about 11 years, represents the waxing and waning of sunspot activity, solar flares, and magnetic field reversals. It is a dance that plays out over decades, moving from a period of calm, known as solar minimum, into a time of maximum solar activity, called solar maximum. At solar maximum, the Sun's magnetic field is at its peak intensity. The number of sunspots grows, and solar flares become more frequent and more intense. The Sun's magnetic poles are at their most unstable, and the Sun's behavior becomes far more unpredictable. In contrast, during solar minimum, sunspots are sparse, and the Sun appears much calmer, with few solar flares and a more stable magnetic field. But this cycle is not perfectly predictable. Though the solar cycle averages 11 years, the length can vary slightly. Sometimes it's a bit shorter, sometimes a bit longer. Yet, despite this variation, the cycle remains one of the most reliable patterns in the sun's activity, something that allows scientists to study its rhythms and anticipate periods of increased solar activity. But even with our advanced tools, the exact timing and intensity of these solar bursts can still catch us off guard. You might be wondering, why should we care about these sunspot cycles? After all, the sun is 93 million miles away. How could its magnetic rhythms affect us here on Earth? The answer is in the space weather generated by solar activity. While the sun may seem distant, its influence reaches far beyond its surface. During times of heightened solar activity, powerful solar flares and coronal mass ejections, CMEs, send waves of charged particles toward Earth. These waves travel at speeds of up to 2 million kilometers per hour, impacting Earth's magnetic field and causing what's known as geomagnetic storms. These solar particles interact with the Earth's atmosphere, causing spectacular auroras, the northern and southern lights. But not all effects are beautiful. Powerful solar storms can disrupt satellite communications, GPS systems, and even radio signals. In some extreme cases, the electrical surges caused by solar storms can fry transformers and knock out power grids, leading to widespread blackouts. And it's not just our technology that's at risk. Solar storms can also affect the health of astronauts working in space, as well as aircraft flying at high altitudes near the polar regions. These high-energy particles can interfere with sensitive electronics, even causing radiation damage to spacecraft. So, what drives this seemingly mysterious solar behavior? The key lies in the sun's internal structure and its incredible dynamo, the process that generates its magnetic field. The sun is a massive ball of plasma, ionized gas, in which particles move in convection currents, much like the boiling water in a pot. These currents carry heat from the sun's interior to its surface, but in the process, they also twist and tangle the sun's magnetic field. As these convection currents move and interact with each other, they create complex magnetic fields that are constantly shifting and reconfiguring. Over time, these tangled magnetic fields break through the surface, creating sunspots. At the peak of the solar cycle, the sun's magnetic field undergoes a dramatic reversal. Its magnetic poles switch places, triggering the beginning of a new solar cycle. This solar dynamo is what drives the sun's activity. And while the sun's magnetic cycle is well understood, there are still many mysteries left to uncover. Why does the sun's magnetic cycle vary in length and intensity? What triggers certain solar storms to be more powerful than others? These questions continue to fuel the quest for understanding the sun's behavior. Given the profound impact of solar activity on Earth, predicting the future of sunspot cycles has become a critical area of research. Scientists are studying the sun more intensely than ever before, thanks to missions like the Solar Dynamics Observatory, SDO, and the Parker Solar Probe. These instruments are giving us unprecedented views of the sun's surface and inner workings, allowing us to better predict the sun's behavior and the potential risks we may face during times of high solar activity. With the data from these missions, we're learning more about the sun's cycles, including how sunspots form, how magnetic fields evolve, and how solar storms can be predicted. Though we're still not entirely able to predict the exact timing of every solar flare, the knowledge we're gaining will help us prepare for the effects of these space weather events on Earth. The sun's sunspot cycles are a cosmic dance, a rhythm of magnetic energy and solar activity that shapes the behavior of our star. This dance, while often subtle, has profound effects on our planet and our technology. By studying the sun's cycles, we gain insights not only into the nature of our star, but into the universe itself. As we continue to unravel the mysteries of the sun, we gain the tools to protect our modern world and better understand the forces at work within our solar system. The sun is far more than a distant source of light and heat. It is a powerful, dynamic force that impacts every aspect of life on Earth. And as we look to the future, understanding the dance of energy that is the sunspot cycle will be more important than ever.